Welcome to Isel Engineering Structural Design Team. My name is Kidana Maram. In the previous tutorial, that is tutorial 1 up to tutorial 6 of ETABS software tutorial, we have seen that how to model projects, how to assign diaphragm on slab, how to mesh slab and wall, how to combine both vertical and horizontal load. Go back and check all my videos. Today, I will show you how to model and how to calculate a dying loads of ribbed slab for 8-story apartment building. After completing watching all my video, you can design and construct civil engineering projects easily. Don't forget subscribe and share this channel to structural engineers, contractors, project owners, civil engineering instructors, and students. Let's start our tutorial. That is how to model analysis and design a ribbed slab for 8-story building. First of all, it's better to go to ETABS software and you have to open your project. After that, it's better to go to plan. So from this, I want to show all the necessary data, that is how to model a ribbed slab, how to assign and calculate load for a ribbed slab from the first floors of your model. So this is the first floor. So I will show this here in three different panels. So first, it's better to delete the loads of delete the previous model of your building. So I'm going to delete all this data. From that, to model our ribbed slab, you have to select your girder beam first, that is to the shorter direction. So to select your girder beam, you have to select the short direction. So the rib must be along to the short direction. So to draw this beam must be your girder beam. So from this check, okay, our beam is 40 by 25, so it's better to go to define section, frame section. So beam 40 by 25 must be changed into, go to modify property. So our beam depth is 30 by we just make it 60. So you can check another width of beam starting from 40 to 60, 70, and etc. So first of all, it's better to check 30 by 60, 30 widths by 60, 30 depths by 60 widths, and that of concrete grade C25. So you have to change the depths to 300 and your widths to 600 millimeter. So make it okay. I will show this. Okay, our property of beam is changed. So you have to change this. Our girder beam is along x direction, along x direction. So it's better to change your beam. That is, our ribs are transfer load to the girder beam. So the other beam, you have to change the dimension or the cross sections of this beam because it's not the main beam, because the loads of the rib is transferred to the main beam, that is the girder beam. So go to define frame section. So starting from this our beam, that is beam. Okay, your beam 30 by 60 is our girder beam. Make it girder beam. Make it okay. So starting from your girder beam, add a copy of. So make it beam that is 30 widths by 30 or 30 depths by 30 or 40 widths. It's better to use 30 widths. So have to change only the depths. So make it okay. So after this, you have select this beam along the y direction. Select all the beam along the y direction. Select the beam along the y direction, and you have to change it because it is not the main beam or the girder beam. So select it. It's secondary beam. So have to select as go to assign frame section. So beam 30 de beam 30 depths by 40 widths. Make it okay. Automatically it changes. So make it extrude frame and extrude shell. So okay, it's not changed. So I will show it in the next part. So what about here? Okay. After this, you have to go to draw your ribs. So to draw your ribs, it's better to define your ribs first. So go to define frame, go to define section property frame section. So after this, add new property, add new property, our concrete rectangular. Under this, you have to select the shape, this T shape. So uh, rename it as a rib. So material property that is C25. After this, you can change the color to this. So section property concrete T. After this, you have to modify all this data. Total depths. Total depths is the depths starting from here to here. That is by subtracting uh, the sections or the thicknesses of your block. That is 40 millimeters. So total depth is 300 minus thickness of the block below the ribs. So that is 40 millimeters. So total depth of your rib is 260 millimeter like this. So total width is the width is starting from here to here. That is 400. So 400 millimeter. Flange thickness is uh, flange thickness. Oh, total width is flange thickness. After this, it's better to draw your ribs along the girder beam direction. To draw your rib, it's better to define first your ribs property. So go to define, section property, frame sections. So from here, add new property. So concrete tray, select this T-shape. Okay, after this, rename it as a rib. So material property, right click on it and make it C25, or you have to select C30. So it's better to change the color. Can change and select any of this color. So it is better to use this color. So the shape is concrete. So from here, it's better to modify this all these properties. So total depth is the depth from this to this. So to calculate the total depth of our slab is 300. So it's better to subtract the thicknesses of the block at the bottom, that is 40 millimeters. So total depth of the rib is 260. Total width is the width of the rib from here to here, that is 400 millimeter. And the flange thickness is nothing but it's the thickness from here to here. So the flange thickness, you can use a flange thickness of 18 millimeter or 100 millimeter. So it's better to use 100 millimeter here. So wave thickness at the flange. Okay, wave thickness at the flange is the distance. Wave thickness at the flange is the distance between here to here, and wave thickness at the tip, that is from here and here, which is a similar thickness. So for the flange, you can use 80, or you can use sorry, the flange thickness. The for the flange thickness, it's better to use 60 up to 80. So it's better to use 80 millimeters. So for the web, it's better to use 100 and 100. Our ribs looks like this. So make it okay. Duplicate file name. Okay. So make it a rib 2. Make it okay. So this is rib 1, rib 2. Okay. So I have defined rib 2, our ribs like this. So it's better to draw your rib on one panel, and I have also show you how to calculate the loads of the rib from for one panel. So it's better to select this panel. I will show you how to draw the rib in X and Y direction. So I have to select to draw your ribs in this direction. So to draw, after drawing your ribs, I will show you how to calculate the load that we are going to assign on this panel. So to draw your ribs, go to define. To draw your ribs, I have to go to draw. So select draw beam and column and objects. Go to quick draw secondary beam. After this, you have to select your property as rib 2 that we have going to define. So movement relay, that is pinned. So spacing, number of beam, not number of beam. We have to select a maximum spacing. So the maximum spacing between ribs is 400 that I have shown you. So parallel to Y, or uh, you can draw like this if you have to use parallel to Y, because our girder beam is from toward the x direction, so the ribs must be toward the y direction to transfer the load to the girder beam. So if your girder beam is along the y direction, to draw your rib you have only change this to parallel to x. So it's so simple. In our case it's better to draw your girder beam like this. After drawing and modeling your ribs and girders like this, I will show you how to calculate and assign the load to the ribs. Okay. Uh, from the previous tutorial, that is how to assign load, I will show you our load case. So go to define load pattern. So in the load pattern definition menu, you have partition wall load, floor finish load, live load, and dead load. So I will show you how to calculate and assign partition wall load and live load for as an example. Okay. For example, in this panel, if you have calculate total 3 kilonewton per meter square. This is an example. So assume this panel has a 3 kilonewton per meter square partition wall load. So to assign on this rib, it's better to multiply it to the spacing, that is 0.4. So to do this, go to Excel. Go to Excel. So if you have to consider this panel has a live load of 3 kilonewton per meter square, and this 2.8 kilonewton, and this 2.8. So you have to select the maximum panel load. And if you take 3 kilonewton per meter square, 3 kilonewton per meter 3 kilonewton per meter square. So uh, it's better to use to distribute this load to all the ribs. You have to multiply it by the spacing of the ribs, that is 3 times 0.6, which is equals to 1.8. So 1.8 kilonewton per meter. You have to get 1.8 kilonewton per meter load to all the ribs. So as a partition wall load. So you have to assign this load by selecting all the ribs. By selecting all the ribs. This is all the partition wall loads on the panel. So go to assign frame distributed, select partition wall load. So make it 1.8. Okay. So all the partition wall load on each rib is assigned like this. You can do it in similar way for live load by multiplying the live load, that is 2 kilonewton per meter square for internal partitions divided by 0.4. So you can assign like this, and you have to assign your girder beams By selecting edge and calculating the load, you can design in similar way. Don't forget subscribe and share this YouTube channel to all your friends. In the next tutorial, I will show you how to analyze and design basement plus ground plus 5 plus terrace apartment buildings that we have model and combine and analysis the load. Thank you. We will meet in the next tutorial. Goodbye.